Alrighty then, let's see. Looks like medium, rotate image. 48, this is really a low number. It seems like I might have done this at some point, but I guess not. Whatever. You're given an n by n 2D matrix representing an image. Rotate the image clockwise 90 degrees. You have to rotate the image in place, which means you have to modify the 2D matrix. Do not allocate another 2D matrix and do the rotation. So 1 appears here. 2, 3 appears there. Yeah. Okay. So how to do this? In place without another 2D matrix. So so 1, 2, 3. It's n by n, so it's square. So 1. So 1, 2, 3. It's like a twister. It's like a twister. So 1 hops to here. 3 hops to there. 9, 7. So it's like 1, 3, 9, 7 is what's being kind of moved around. Same with 2, 6, 8, 4. If this was a 3 by 3, it'd be like, no, it is already 3 by 3. If it was a 4 by 4. So the 1 goes to 4, 4 goes to 16, 16 goes to 13, 2 goes to 8, 8 goes to 5, 5 goes to 9, 9 goes to 2. So there is a cycle there. There is a cycle there. I wonder if there's a kind of elegant way of doing this. Like, what does this come to mind? There was a way of swapping two numbers without using a third variable. It was like if x is 10 and y is 15, then you do something like y becomes 25 and then x becomes 15 and then y becomes 10, something like that. So you do you make, I don't even know how to represent, but like you make 1 the sum, and then you, I guess in that case, you make the other variable back to complement, right? Because the 10 and 15 are complementary parts of 25. So you make 1 the sum, you make the other, you kind of make the other the complement back. And then you again make the other y complement. Can you do that with multiple? Or else maybe, well, mostly you need 4 variables. I have temporary variables here. So maybe overthinking this. 1, 4, 16, 13. So the the four positions that yeah, okay. No big game that shit. It's fine. It's fine. Okay, let's say n is equal to, this is just very algebraic, I think. Length of the matrix. I just need to find for is this nest for loop, I guess? For every row in range n. I think I'll use R and C. R being the row index. And then for every column in range, so if it's row 0, I want to start with column 0, but if it's like row 1, I want to start with column 1. So I think this should be if it's a 4 by 4, then it should be just row 0 and row 1. Or, yeah, row 0, row 1, column 0, column 1. So I think this should be R. Yeah. Because I want to have this position go across, and then this position, or like this position 6 and go across to 7. So it'd be C from R to n divided by 2, n divided by 2 minus 1, n minus 1 divided by 2. I would, if this was a 3 by 3, if this was a 2 by 2, I do need to go 1. If it's a 3 by 3, I need to go 1. So it's rounded down. It's 4 by 4 needs to go 2. Okay, yeah, I think it's 3. Locate the 4 positions that are rotated through from R, C. Okay. Can you just make a horribly long expression here? Or I can make it more complex or compactified. Let's say A, B. No, I can't even use variables here, right? Because I need to actually store it back into the thing. It's fine. A, B, C, D is equal to matrix at RC. Matrix at, so this position here is like 2 would map to 8. 2 would map to 8. So the row would map to the column at that point. Row 0 and then max column. So the column parameter here. So I'm thinking 1 goes to 4, 2 goes to 8. 2, 8, 15, 9. So 2, 8, 15, 9. 2 is in row 0, column 1. 8 is in row 1, column 3. 15 is in row 3, column 0, 1, 2, 3, column 2. And 9 is in row 3, no, row 2, column 0. So we need to make this kind of algebraic, right? RC I want to say if this is RC, this should be like C n minus R, and then this is going to be n minus R for the row, and then n minus C for the column. And then this last one is going to be I think this last one is going to be n minus C for the row and R for the column. I think those are right. Well, I mean, I didn't do a lot of method checking here, but this should be C n minus R, n minus R, n minus C. N minus C, R. Okay, and then I need to transfer those. Okay, matrix at RC. This should be D, right? D goes to A. Matrix at C n minus R. Let's go to A, matrix at n minus R, n minus C is B, matrix at n minus C, R is C. And that might be it. Out of range. Well, oh, it's supposed to be n minus 1, I think. Yeah. Because n is 4, not 3. N minus 1. Whoopsie. So all the references of n become n minus 1. Still out of bounds. Unfortunate. Oh yeah, we need to change these references. N minus 1 minus R, n minus 1 minus R, n minus 1 minus C, n minus 1 minus C. Out of range. Huh. Really? Matrix at RC. Equals D. I didn't think this goes out of bounds. For every row, for every column. Matrix at RC equals D. I mean, the issue is, like, if this is out of bounds, then how did this work? Like, what the heck? Matrix at RC. Okay, let's go ahead and just print out where it's crashing. It's crashing at 0, 0. Excellent. Yep. Y. Index out of range. R 0 columns, rows 0 columns 0. I must be thinking of something really wrong here. I must be thinking something really, really wrong. Matrix at RC. This assignment index out of range. This assignment index out of range. I'm so fucking stupid. C is the column index. A, B, C, D is just killing off C. So stupid. Okay. Okay. I'll just do X, Y, X, W, X, Y, Z. So the 7, so the 1, I move the 1 to the right spot. The 1 to the right spot. So the 1 moved there. The 3 didn't move to the right spot. The 3, no, 3 did move to the right spot. So 7, 1, 3, and 9 are in the right spots. Didn't transfer the other ones right. I didn't transfer the other ones at all. I don't think. Yeah. Yeah, this is strong. This should be, let's say n minus n divided by 2. Is that right? No, it's like n minus r. N minus 1 minus r, or n minus r. N minus 1 minus r. No, I think it's n minus r. No, so if it's the first row, I don't want to do the last. I don't want to do the last column. Okay, I think it's n minus 1 minus r. Okay. Okay, sure. All right. Summary. Is incorrect. Above algebra is incorrect because n should be n minus 1 instead, otherwise fine. Alright, so the summary here is use a nested for loop to iterate over the appropriate positions. For position RC, there are 4 positions that are relevant to its rotation. Find the algebraic expressions that map to those positions. Pull values from those positions and assign them to the next position in the rotation. Some minor adjustments need to be made to iterate over the correct positions. Although in theory you could do all positions. And be slightly slower. Like my bounds for my loops are going from 1 to, or 0 to n basically, and C going from R to n minus 1 minus R just prevents, does it prevent it actually? I think I could actually go R from not 1 to n, but 1 to n divided by 2 maybe, because you don't rotate past divided by 2. I think that's right. Okay, yeah. No difference in the runtime, but it is faster, or it is slightly improved because you don't actually need to go through all n. Your initial position is just the first kind of unique position on the top right of the rotation, or top left of the rotation. Yeah. Yeah, so I mean, you can, I pulled out 2, 8, 15, and 9 from the 4x4, map the first position 2 to say that's algebraically RC, and then try to find the what logically makes sense for the algebraic expressions to define the other positions. And then with that generalization, I went ahead and applied that to the code. So just kind of making sure you do the algebra right. Time complexity, this is going to be O of n squared, since you need to iterate over all the starting positions of the rotation. But that's pretty obvious. You need to at least do every position once. Base complexity is over 1. So next